When you look up, every star, every galaxy you've ever seen, what if it's all part of a cosmic illusion? What if the universe isn't what we think it is? What if, right now, as you're watching this, you're already trapped inside one of the universe's most extreme and violent places? This is Stellar Stories, and in this video we ask, is our universe inside a black hole? Think about it. Could our Big Bang have been less of an absolute beginning and more of a big bounce from a black hole that formed in some other universe? Ever since we proved black holes were a thing, the whispers have been there. Could our entire universe just be a cozy little pocket within one? The parallels between black holes and our universe are oddly compelling, and we're about to dig into exactly why. We're talking the black hole universe hypothesis, a theory that might just clear up some cosmic headaches, or give us entirely new ones. You know the drill. Black holes are where gravity goes to break all the rules. Born from the dramatic collapse of massive stars, these aren't just dense objects, they're literal rips in the fabric of space-time, sucking everything into a point of no return. That event horizon, it's the ultimate cosmic boundary. Cross it, and you're done. No escaping that inescapable pull. Anything that tumbles in is sealed forever, behind the ultimate prison wall. And at the heart of it all, the infamous singularity. This isn't just dense, it's infinitely dense, a place where our physics taps out. We're still grappling with what truly happens there, if it even exists as we imagine. But for now, think of it as the black hole's mysterious, unknowable core. So, in short, collapsed stars, gravity on steroids, a one-way ticket past the event horizon, and in a very real sense, a universe-breaking singularity at the center. Now we can really dive into the deep end. Alright, let's get into the nitty-gritty of the black hole cosmology idea. At its core, it proposes that our entire observable universe is just the interior of a black hole, nestled in a much larger parent universe. And yes, it gets even wilder. Every black hole in our universe could theoretically be spitting out its own baby universe. Think cosmic nesting dolls, where universes recursively birth new ones through black holes. This isn't exactly new. Physicists like Raj Pathria and I.J. Good were kicking these ideas around decades ago, and Nikodem Popławski has championed them more recently. So, how does this actually work? It's all about some striking parallels between black holes and our universe. First up, singularities. A black hole has one at its center, that infinitely dense point. And our Big Bang is often described as starting from a similar, infinitely dense state, a singularity in time. The black hole universe hypothesis suggests our Big Bang was effectively the inside of a black hole's collapse in that parent universe, a big bounce, rather than a true origin from nothing. Extreme quantum gravitational effects could have caused a rebound, launching our universe into existence. Then there's the event horizon of a black hole, the point of no return. Our universe has a similar limit, the cosmological horizon, which defines how far we can see due to the universe's age and the speed of light. The black hole cosmology theory directly equates these two. Our cosmic horizon is literally the event horizon of the black hole we're supposedly in. No information gets in or out. Next, the center of expansion. Our universe expands, but there's no central point. Galaxies aren't flying away from a single origin. Space itself is stretching everywhere. This fits surprisingly well with being inside a black hole, especially one that bounced. The original singularity isn't a place we can point to now. It was an event in the distant past, the Big Bang. So from our internal perspective, we see expansion, not collapse to a central point. Now the big one, if we're inside a black hole, why are we expanding, not collapsing? This is where the physics gets a tweak. The idea suggests our black hole isn't a typical one, but more like a white hole in disguise, the time reverse of a black hole, spewing matter outwards. While standard general relativity says white holes are unstable, theories like Einstein-Cartan gravity propose quantum effects, like space-time torsion from spinning particles, could create a powerful repulsive force at extreme densities. This could prevent an infinite crunch, causing a big bounce, that then expands into a new baby universe on the other side of an event horizon. This means our universe's expansion could simply be the outflow from that white hole, the other end of a black hole collapse elsewhere. This whole black hole-white hole connection often brings up wormholes or portals. While fully traversable wormholes are still sci-fi, the underlying math from Einstein's equations does allow for non-traversable bridges, like the Einstein-Rosen bridge, connecting external and internal regions. So our Big Bang might have been a one-way tunnel connected to a parent black hole. Finally, physicist Lee Smolins' cosmological natural selection, or fecund universes theory, takes this further. He suggests that universes reproduce through black holes, and each baby universe might have slightly different physical constants. Those universes whose laws of physics are better at forming black holes would reproduce more effectively, leading to a kind of cosmic evolution that could explain why our universe has the properties it does, like why our fundamental constants allow for stars and life. It's a vast family tree of universes, with us as just one branch. So, why entertain this black hole universe idea? It's fair to ask, is this just a neat thought experiment, or does the black hole universe hypothesis actually do anything for us? Turns out, it's a serious contender for solving some of cosmology's most annoying headaches. First off, it kills the Big Bang singularity. No more magic moment where physics breaks down. Instead, our universe's beginning was a big bounce, the aftermath of a collapsing star or universe in some prior reality. Think of it as a continuous cosmic narrative where the Einstein-Cartan theory allows for a repulsive force from space-time torsion that stops infinite crunch and creates a new, expanding universe. Popławski's work in particular shows this model can be consistent, giving us a Big Bang that's a continuation rather than an absolute start. Then there's inflation, that rapid expansion right after the Big Bang, which was invented to fix the horizon and flatness problems. Guess what? A black hole bounce naturally produces similar effects. The torsion that drives the bounce can also create an exponential expansion, smoothing out irregularities and pushing the universe towards flatness, just like inflation does. So, our universe being born from a black hole could automatically come with its homogeneity and flatness built in. It even takes a swing at dark energy, that mysterious force accelerating our universe's expansion. The same torsion effects causing the bounce could also generate a persistent cosmological constant in our baby universe, behaving just like dark energy. Some even speculate that inherited spin from a parent black hole could contribute. And let's not forget the cyclical cosmos angle. This theory offers an elegant answer to what came before the Big Bang. Another universe's collapse. It's a self-perpetuating cosmic ecology where black holes act as wombs for new universes, potentially forming an eternal chain. It's a multiverse with a purpose, linking the vastness of cosmology to the extremes of black hole physics. Ultimately, the allure is clear. The black hole universe hypothesis offers a unified solution to a whole suite of cosmological puzzles, removing the Big Bang singularity, providing an origin story, baking in inflation-like effects, explaining homogeneity, flatness, and even offering insights into dark energy and dark matter. It's almost too good to be true, which is why it gets taken seriously by some as a genuinely elegant answer to why is our universe the way it is. As much as the universe inside a black hole idea tickles the imagination, it's currently in the highly speculative pile for good reason. It's got some big hurdles to clear before it graduates from cool thought experiment to accepted theory. Let's face it, extraordinary claims need extraordinary evidence, and right now, we're fresh out. Here's why most scientists remain unconvinced. There's no smoking gun, observational evidence is MIA. We've peered at billions of galaxies, meticulously mapped the cosmic microwave background, and surveyed the universe's grand design. And guess what? Nothing screams, we're trapped in a black hole. There's no clear edge or weird imprint that demands this explanation. That recent flutter about galaxies rotating in a preferred direction. Intriguing, sure, and Shamir did link it to this idea. But other astronomers quickly pointed out potential biases and lack of widespread confirmation. As cosmologist Paul Sutter bluntly puts it, the evidence doesn't lead us in this direction at all. Our good old lambda CDM model, Big Bang plus dark matter plus dark energy plus inflation, still fits the data like a glove, and the bar for a radical alternative is sky high. It runs into the unfalsifiable problem. By its very nature, if we're inside a black hole, anything beyond our cosmic horizon, like a parent universe, is fundamentally unobservable. We can't see it, we can't talk to it. That's the whole point of an event horizon. This makes direct testing incredibly difficult, verging on unfalsifiable. While indirect tests, like looking for a universal rotation axis inherited from a spinning mother black hole, have been proposed, results have been inconclusive at best. Until it makes a unique, testable prediction that differs from standard cosmology and we can actually observe it, it largely remains in the realm of philosophical discussion. It also requires new physics, and we haven't found it yet. For a black hole to bounce into a new universe, our current understanding of general relativity needs a significant upgrade. It requires invoking quantum gravity effects, like those described in the Einstein-Cartan Sciama-Kibble theory, which adds torsion to gravity. While mathematically plausible, we have zero experimental evidence that nature actually uses this extra physics. Critics also point out that theories like Smolin's fecund universes, which suggest physical constants are passed on, might clash with black hole information paradoxes. If information can't escape a black hole, how do these baby universes inherit altered traits? Why invent a whole new layer of speculative physics when our simpler standard model is doing just fine? Thank you very much. Then there's the same old problem that quantum gravity's still a mystery. The whole idea of a bounce instead of a singularity relies on a theory of quantum gravity, something we don't yet have. The black hole universe is one guess among many, like eternal inflation, colliding brains, other cyclic universes, about what happens at those extreme conditions. The interior of a black hole is a cosmic black box, and until we have a robust, proven theory of quantum gravity, any claim about what happens inside is pure conjecture. Then there's white hole stability. For our universe to be expanding out of a black hole, it would essentially need to behave like a white hole, a region that only expels matter. But standard general relativity predicts white holes are incredibly unstable, collapsing instantly if even a single particle falls in. Proponents argue that because our white hole is disconnected behind our horizon, it avoids this instability. But this is a bit hand-wavy. Critics demand rigorous mathematical proof that such a solution could persist for billions of years. But I'm definitely blaming the flakiness of white holes for my last video flopping. And now, the pesky problem of infinite regress. In other words, where did the mother universe come from? Even if our universe was born from a black hole in a parent universe, you've just punted the origin question up one level. Where did that universe come from? And the one before that? You can end up with an infinite chain, which some find appealing, but others see as merely deferring the ultimate mystery of creation, not solving it. It trades one conundrum for another. In a nutshell, while the black hole universe hypothesis is a thought-provoking, even elegant idea, it lacks the crucial evidence and theoretical robustness to sway the scientific mainstream. It's a beautiful alternative, but it's not even close to being proven. But it pushes us to question our assumptions and explore the wild frontiers of cosmology, and that's valuable, even if we ultimately conclude we're not literally living inside a cosmic black hole. The take-home message is one of awe and humility. Our universe, whether born from a black hole or not, is an incredible place where reality often outstrips imagination. We've gone from thinking black holes were mere theoretical oddities to imaging their shadows and pondering if they create whole new universes. As you stare up at the night sky, consider this. There was a time when the idea of other galaxies, the expansion of the universe, or black holes themselves sounded outrageous. Today, those are established facts. So who's to say that today's wild idea, like cosmic reproduction via black holes, won't be tomorrow's accepted science? Stay curious and keep questioning. The next profound discovery about our cosmos might be lurking in such what-if questions. The pursuit of knowledge requires us to occasionally wander down speculative paths. Some will dead end, but others might lead to the next revolution in understanding. If nothing else, thinking about living inside a black hole gives us a fresh perspective on our place in the cosmos, highlighting how much we have yet to learn. At the very least, pondering our existence within a black hole gives us a truly fresh perspective on our cosmic place. It hammers home just how much we still have to learn about this wild, magnificent universe. So, keep those big questions coming. Who knows what profound discoveries are lurking just around the corner, waiting to be unveiled. And hey, if you like this stellar story, please consider liking and subscribing. It really helps me out being a tiny channel. I respond to all comments. See you next time.